In question 8, we're given that f equals k small q times large q upon r squared, and we're asked to find the percentage change in f due to the following accuracy figures for the three independent variables, small q, large q and r. And if you look in the formula sheet or look in the notes on small changes under partial differentiation, we'll see that we can form an equation for delta f, the change in f, in terms of its partial derivatives. Partial df by the small q times delta q plus partial df by the large q times delta large q plus partial df by dr times delta r. So if we look at f, partial df by the small q, partial differentiation, anything that doesn't contain the small q is going to be so basically times small q, and the derivative of a constant times a variable is just the constant. So partial df q is just the surrounding constant k times large q upper squared. Similarly, partial df by the large q, well, f is a constant times large q, and therefore partial df by the large q is going to be the constant multiplying large q, so k times small q upon r squared. And lastly, partial df by dr, well, here we're better to think of f as being equal to k small q large q times r to the power minus 2, which is the same as 1 upon r squared. But then that allows us to apply the power rule for the derivative of a power, and so we get this time the constant k times small q times large q times the derivative of r to the minus 2, which is minus 2 times r to the minus 3, or minus 2 upon r cubed. And the next step is to take the original f as a common factor, and then inside the brackets we're going to have delta small q upon q plus delta large q upon large q minus 2 upon r delta r. We can determine what each of these terms in the bracket should be by dividing the original three terms by f. Not straightforward to see how those go, but because they're both fractional terms. But remember, dividing by a fraction is the same as multiplying by the inverse of the fraction. So in fact, if you imagine multiplying each of these terms by, instead of f, the inverse of f, so r squared upon k small q large q, then that tells us what the three terms in the bracket should be. And this then allows us to say that delta f upon f is therefore equal to what the terms in the bracket. And of course, the question's asking us to find the maximum percentage value for, or the maximum of delta f upon f, maximum magnitude. Magnitude we can indicate using these parallel lines, vertical lines. So the maximum of this will be equal to the sums of the maximums of the individual percentage changes. So here this is going to be 1% plus 3% plus 2 times the magnitude of minus delta r upon r, which is going to be 2, so plus 2 times 2%, giving a total of 8%.